Okay, the purpose of this depth study feedback video is just to go through a couple of things in the discussion. I've just included the discussion marking scheme here, which you're probably familiar with now, and I'll just go through a couple of things to look out for. Okay, so the first thing, I'll just go through how I marked the first bit. First bit was just validity, reliability, accuracy, and sources of error. Okay, so the way I did this was I basically just gave 1 mark for each of these correct. So reliability, you just had to say repetition with consistent results, and you had to talk about that. Accuracy, you had to say how close your results are to the expected result. Validity, you just have to assess whether your method tests the aim. And error, you just had to identify some errors in your experiment and go through those. With these, quite often, what I was looking for people to use their data and evidence from their results. So a lot of people just wrote vague things. They wrote things like, "Oh, my results were reliable." You should be writing things like, "My results were reliable. Um, in my experiment with the bumper, I found that the maximum force was 25 newtons, 26 newtons, and 27 newtons. As you can see from this data, that it was consistent each time." So that's the sort of thing you want to have. So you want to communicate evidence that shows that your experiment was reliable, accurate, valid, and so on. Okay, so I've included a exemplar down here, for example, for accuracy. So for accuracy, this person actually went through. This is one that a lot of people struggled with because they didn't know what their expected result was. But your expected result is simply to reduce the force when you've got your bumper attached to your trolley. So what the person did is he went through and he showed using correct notation and language. He used physics language, not just vague, made up language. And he went through and he actually calculated the forces, okay, and actually determined the percentage change of his crumple zone compared to without his crumple zone, okay. So that's a sort of, I suppose, way that I would expect a Year 11 student to address reliability, validity, and accuracy. They would have some sort of discourse, something like this. Okay, so have a look when you get yours back and see what you wrote, reflect on what you've got there. The second part of the marking criteria was what went well in the experiment, what didn't go well, and what would you change in the future if you're repeating the experiment. Now, this was pretty poorly done. A lot of people wrote this like as a reflection, like a journal entry, but you're in a discussion of an experiment, so you really have to use scientific language and you have to put forward the scientific knowledge that has been established through conducting the experiment. So in this part here, what went well in the experiment, some people talked about, "Oh, I worked well with my partner," and so on and so forth. Okay, that's not really what we're looking for. We're really looking for you to refer to your results, refer to your bumper design. Okay, so what I was really looking for was for you to kind of link together your bumper features and the design features of your bumper and the data that you got in your results to determine what went well and what didn't. And I expected you to do that using correct physics language, if you like, and knowledge. So I've got an exemplar down here of that, and see here. So I've got here, you'll notice here, what went well, the aim was completed, bumper was created with an effective crumple zone, and he's addressed that it's effective because he said it reduced the peak force by an average of 84%. That's a sort of discourse that's required here. What didn't go well? Recording, the hertz rate, so that's the resolution of the data, and so on and so forth, okay? And then in the third bit, this person here has gone and addressed the design of the model and so on. So when you're writing your discussion, I think it's very important that in your discussion you refer to the results data, okay, and make sure that you're linking your discussion to the knowledge that you've gained in doing the experiment. Just one other one quickly that I want to address before I go is in addressing the errors, a lot of people are writing human error, okay? And I've written here human error is not an error. If you think you've got human error in an experiment, it's more than likely that this is pointing to an error in your method, okay? So what you've done is you haven't established a series of steps in your method, okay, that will make your test valid. So you want to, if you think you've got human error, you want to go back to your method and just check, is there something in there that is kind of taking away from the validity of your test, okay?